Okay, so the goal of this video is to determine if this function of two variables, m and n, equal to m plus n, is one-to-one and onto, where we define our inputs to both be integers. Remember that an ordered pair is said to be a member of the cross product or Cartesian product between two sets. In this case, they're both integers. And our output is also an integer. Now, one-to-one, remember, means that no two inputs are going to give the same output. And we automatically can see that this is not going to be one-to-one. Just as one of many counterexamples, if we did f of 1 comma 3, that would be 4, and so would f of 3, 1. So there is no way that this is one-to-one. In fact, functions of two variables like this are very seldom one-to-one. I'm actually blanking on, can I find a function like this that's one-to-one? So it's just not going to happen with this kind of a function. So our only hope is that maybe it's onto, and notice that the fact that it's not one-to-one definitely disqualifies this from being a bijection, which means it's a one-to-one and onto function. So is it onto? Well, I want you to think about, and you can pause the video if you like, think about an integer that you cannot get from adding two other integers. And it's kind of hard to think about that, right? So maybe we'll go the proof route and say, I'm going to let b be a member of the codomain, which is the integers here. Okay, so I'm going to say f of mn equals m plus n equals b. And we want to show that there exists an m and n such that m plus n equals b. Well, so what we want to do is make sure that whatever we choose for inputs, that they are integers and that they add up to b. Well, there's a lot of options here. We could say m equals 1 and n equals b minus 1. We could say m equals 2 and n equals b minus 2. And if b is an integer, we know that adding or subtracting another integer to it is going to give you another integer. So here we have several solutions, okay? So therefore, f is onto. And that pretty much sums it up.